Hello, everyone. Welcome. My name's Charlie Turcott, and you are attending the Dale Prentice Company and VRC Protx Rupture Disc Common Application Issue Training. We'd like to welcome you, and we'd also like to let you know if you are an engineer who holds a professional engineering license, you are eligible for continuing education credits for this training. So today I'm going to be starting the presentation. My name's Charlie. I work for the Dale Prentice Company. I'm based in Grand Rapids, Michigan, on the west side of the state, out of my home office. And then my coworker, Doug, who manages our overpressure protection product lines at our sister company, VRC Protx. He's going to be doing the latter half of the presentation. Feel free throughout the presentation to submit questions into the chat that you'll see on the right-hand side. We'll be addressing them at the end. If any of you are unaware of the relationship between our companies, the Dale Prentice Company is a manufacturer's rep that focuses on process safety and automation. And we own and operate a valve service and process safety company called VRC Protx, which does a lot of our hands-on and engineering work, including our pressure relief valve sizing, explosion protection design, and automated valve engineering and installation. So we employ technicians, engineers, and field salespeople that support those applications. In Michigan, we have 3 locations, and then we have salespeople who work remotely throughout the state as well. In the Great Lakes region, we have locations in Wisconsin, Minnesota, and then as you get further out west, we have locations in Utah, the Dakotas, and much of the Rocky Mountains. The Dale Prentice Company is a manufacturer's rep for Fike Corporation, which builds process safety equipment, including rupture discs, but they also build and design fire protection systems and explosion protection systems. They're a family-owned company based in Blue Springs, and they are a very good manufacturer and company to work with. That are relevant to their design, rupture disc design itself, and then use and operation. And then Doug's going to be taking over the latter half of the presentation. He's going to talk about application issues. Two important resources for rupture discs would be the Fike Knowledge Center itself. That's what this presentation was built off of. And if you're looking for more of an in-depth dive into pressure relief, AICHE has a lot of resources. So if you want to be the subject matter expert on overpressure protection for your company, that's a good way, that's a good resource to get there. So some of the most important definitions that you'll need for this presentation are pressure relief device, set pressure, accumulation, capacity, and back pressure. A pressure relief device is any device that prevents excess vacuum or pressure from accumulating in a vessel. The operation of that device could be during an emergency or just an otherwise abnormal operating condition. Set pressure is when that device opens. It's important to know that different pressure relief devices open in different ways. That can vary depending on just the style of device, but even between manufacturers, there's different opening characteristics for different applications. That's important to keep in mind. Accumulation is the amount of pressure that builds in the vessel while the PRD, pressure relief device, is open. Capacity is how much fluid that device flows per unit time. And back pressure is the amount of pressure that exists at the outlet of the device. Now, there's different types of back pressure depending on the process, but we're not going to go deep into that today. The most important body when it comes to process pressure protection is ASME. ASME writes the boiler and pressure vessel inspection code, and then they designate the National Board of boiler and pressure vessel inspectors to audit and inspect devices and equipment that's pressurized and stamped as an ASME vessel or device. So ASME writes the rules, and then the national board does the groundwork. On any pressure relief device that falls under ASME's jurisdiction or is approved by ASME, you're going to see a code stamp. So that code stamp identifies the type of application that device is approved for. Now, not all pressure relief devices receive an ASME code stamp. ASME kind of draws the line at 15 pounds gauge, so devices under that set pressure fall outside of ASME code. Not that there's not a hazard present, that's just how the code is written. And then if you're above 15 pounds gauge, the most important code stamps are Section 1 and Section 8. Section 1 designates that that pressure relief device is to be used on a fired vessel, like a boiler or a water heater that's of a certain temperature and pressure rating. And then Section 8 is for all non-fired vessels. So that could be a steam line, that could be compressed air, or a compressed liquid. On a rupture disc, you're most often going to see, well, actually, there's no Section 1 rupture discs because it's reserved for boilers. Section 1 really just applies to relief valves. And then a rupture disc is either going to be Section 8 or it will have no code stamp. That's something that you can specify. If it's a non-code application, the rupture disc just won't get a stamp on it. Section 3 is also used for nuclear, so we don't run into it often. There's two major styles of discs. There's a forward acting disc and a reverse acting disc. The forward acting disc was invented first and it's more common. All it means is that the concave side of the disc is pressurized. So the outward facing side is facing away from the pressure. And the way it ruptures is different than a reverse acting disc. So you would choose between the two depending on the application. And that's something that you could talk to one of our inside or outside salespeople about. So the reverse acting disc is just the opposite. The concave side is flipped, or the convex side is the side that's pressurized. And that also alters how the disc opens in response to pressure. There's many different holders. And when you think about a rupture disc, you should always think about it as not just the disc itself, but as the complete assembly, the disc and holder, because the disc is also what creates that seal against pressure. So really, even though they're separate devices, the disc's performance is dependent on that holder. One of the more noteworthy holder styles is pre-torqueable. So it's difficult to install some rupture discs between flanges and get all the installation requirements correct, the torquing pattern on the bolts. So most manufacturers now offer a holder style that you can just insert between pipe flanges. Some common causes of overpressure include block discharge, thermal expansion, and exposure to external flames. Most pressure relief scenarios are designed around these three, but that's not to say that other overpressure conditions don't exist. There's a whole litany if you're familiar with overpressure design. These are just the ones we see most often. So block discharge, that could be a manually operated isolation valve, or it could be a control valve that fails on the outlet of a vessel. So you would design a pressure relief device like a relief valve or a rupture disc to account for that situation. Thermal expansion, maybe you have a storage tank or a line that might not be flowing and is subject to radiation from the sun, the fluid's going to expand, so you need something to allow for that expansion. External flames. So if a vessel has a fire underneath it, there needs to be a relief device or several relief devices to account for that condition. So why would you use a rupture disc over a relief valve? Well, it's not just one reason. It's really an engineering decision. You don't just choose between the two based on cost. One doesn't perform better than the other. It really depends on the application. So a rupture disc can be cheaper than a pressure relief valve because a pressure relief valve is a mechanical device and needs periodic maintenance. You may be able to save money with a rupture disc. A rupture disc is a good option if fluid loss is not an issue. So if you had a non-toxic fluid that doesn't cost anything, which is not common, then having a device that just opens and doesn't reclose would be ideal because you don't need to worry about that fluid spilling or going into the atmosphere. They're a lot simpler than relief valves because it's just a disc that opens and doesn't reclose. There's less chance of error or mechanical failure. Excuse me. They respond quicker than relief valves. So for like an incompressible fluid like water, pressure spikes can happen really quickly and cause a lot of damage, and a relief valve isn't going to respond quick enough or to the degree necessary. There's a much larger size range for rupture discs. So if you needed a lot of area to relieve the pressure during a certain overpressure situation, then you can get a lot more square inch area out of a rupture disc. Lower maintenance costs. The only time you need to spend money on a rupture disc is when it's been blown out, which can be expensive if your process pressure gets up high frequently. But if it's a relatively stable process, it can be a lot cheaper than a relief valve. And they can also be used to isolate pressure relief valves. So you can place it on the inlet of the relief valve to prevent corrosion. And you do this if you would otherwise need to use exotic materials for the entire body of the relief valve. You could just have an exotic material for the rupture disc, and then the relief valve could be standard stainless steel. There are 3 ways that you can use a rupture disc. You can use it as a primary pressure relief device, as a secondary, or in combination with other relief devices. So primary relief, that's just the rupture disc alone is protecting the vessel. Secondary or multiple, maybe there's different pressure relief scenarios that you're trying to account for. There could be a block discharge, but the tank could also be subject to external fire. So there's different capacities and set pressures that you would use for the devices. And then it can also be used in series with a relief valve. Make sure if you have any questions, you submit them in the chat. And I'm going to try one of our polls. So for fluids, oh, I got to publish it. For fluids that are blank, the speed at which a pressure relief device can fully open is often a concern. So there is a right answer here. And in case anyone was wondering, the answer was incompressible fluids. The speed at which the device responds and opens is important for incompressible fluids. All right, I will hand it off to Doug.
Thanks, Charlie. I'm assuming you can hear me okay.
Yep, we can hear
So
you.
we're just going to talk a little bit now about things that you might encounter in your plant if you have a rupture disc issue, or things to consider when you're having a discussion with a vendor and thinking about applying a rupture disc for an application. Some of the considerations that you want to keep in mind. This will help you understand some of the questions that the vendor may be asking you, and why those things are important. So we're going to focus a lot on how important it is to properly install and maintain rupture discs. So what you see in the picture here is a rupture disc assembly. The piping is shown there. That would be your system piping. The device that's clamped between the flanges is the rupture disc assembly. And as Charlie pointed out, it's important to always think of these things as an assembly, because with very few exceptions, rupture discs are always installed in some type of a holder. And that's by design. Okay, the rupture disc is designed, it has to perform very reliably, so we have to control the conditions under which it lives in your system. And to do that, we put it inside a holder. So I said most rupture discs are in a holder. There are a couple of designs. You may have seen on the marketplace graphite rupture discs. Those typically are just an inert graphite, molded and pressed, and it's of a design where you can throw a couple gaskets on that and put that in between your mating flanges. But our discussion today is really around rupture discs that are more of a high-tech nature. So the holder keeps the disc centered in the system, or in the flange space. The holder and the disc designed together provide a tight seal. If you can picture the rupture disc in the holder, it's a 360-degree seal around the edge of the rupture disc, and that obviously is very important, because a rupture disc is meant to be a leak-free device where mechanical pressure relief valves can leak or weep a little bit under some circumstances, and that's considered acceptable. In this case, rupture discs are intended to be zero leakage at all times. So the amount of torquing, amount of torque that you put onto the flange studs is very important for maintaining that seal. Alex previously showed you a couple different designs of discs, so some forward-acting discs and reverse-acting discs. We're going to look at a couple of differences between those and how they seat in the rupture disc holder. So when we're talking about getting a rupture disc to seal properly, we're not only talking about the torque on the studs, but it can even get down to the type of lubrication that you're using on the studs. Gasket material is a real big consideration. There are much different torque requirements for standard, say, non-asbestos gaskets or Teflon gaskets versus a flexible metallic gasket. And so when you are discussing application with a vendor, make sure that you're receiving the proper torque requirements for whatever gaskets you're using. So just like anything else in your plant, and rupture discs and relief valves and all kinds of equipment, you are going to want to inspect them periodically to make sure that they're not wearing inappropriately or going to give you some issues. So when you inspect a rupture disc, and we're going to talk about pre-torqueable holders in a minute here, but when you're inspecting rupture discs, you're looking for signs that the rupture disc is seeing unusual wear due to things like pressure cycling or slippage in the rupture disc holder. The picture that you see here, if you look around the left edge in particular there, from about 6 o'clock up to 10 o'clock, you can see small ripples. that's a sign of a rupture disc that has moved a little bit and slipped inside of the rupture disc holder. That can be caused by a couple different things. One is maybe it was not initially torqued properly into the holder. Another possibility is that the rupture disc assembly was removed from between the flanges for inspection, and during the inspection, on a standard non-torqueable holder, the upper and lower halves of the holder that enclose the rupture disc are not very tight, and they can move around a little bit, which then in turn gives the disc a chance to move. Then when you put it back in between your flanges and retorque it, now that disc may have moved a little bit. It's not seating exactly the same, and that can cause performance issues down the line. If your system is seeing a lot of pressure cycling on a disc of this design, you can get something that we call turtle backing, and the center of the disc will have like little divots in it, almost like the shell of a turtle, and that's an indication of cycling wear. Obviously, if you see signs of leakage, that's certainly a concern and should be addressed as soon as possible. And also, we're going to look at some pointers on inspecting the holder for damage. Torquing is probably about the most important thing to consider when you're installing rupture discs, because it really sets the stage for how that disc is going to perform. There are non-torqueable holders and there are pre-torqueable holders. Historically, all the manufacturers made just a standard non-pre-torqueable holder. Within the last several years, most manufacturers now have a pre-torqueable design. I kind of explained the difference between the two in that if you take a disc out of line for inspection, if you're using a non-pre-torqueable holder, that disc could be moving around inside the holder a little bit and become seated improperly when reinstalled. So the general recommendation is if you have a non-pre-torqueable holder and you take a disc unit out of the pipeline for inspection, it's good to inspect it as you take it out so you get a sense for what's been happening or if you're seeing any wear on the disc. But generally speaking, you're not going to want to put that disc back into service. Take it out, inspect it, note any damage, for your inspection reports and whatnot. But then that disc should be replaced at that time. So just like, putting a tire on your car or any other flange in your plant, you want to cross torque the holders into the system. And then after the system is up to operating temperature, you want to go back and recheck that torque and make sure it hasn't changed at all. So here's what a pre-torqueable holder looks like. A non-pre-torqueable holder looks pretty much like this, except those screws around the perimeter of the holder aren't there. It just looks like two machined metal donuts that fit in between in the bolt circle of the flange pattern. The pre-torqueable holder is good for a couple of things. First of all, it can be very nice to be able to install a disc in a holder in the calm and comfort of your maintenance shop, rather than having to put it together and apply your torque when you're up on a lift in a dark area, in a cold area, in a hot area. You can be up there a much shorter period of time if you're using a pre-torqueable disc design. The other nice reason is that when you're handling large rupture discs, let's say you've got an 8 or a 10 inch or even a 6-inch rupture disc, those assemblies can be quite heavy. So if you're pre-torquing that again in the shop and then transporting it out to the point of installation, you're able to handle it and get it up there without having to worry about the disc moving around inside the holder before you get things torqued. The next thing that is an advantage of a pre-torqueable design is, as we talked about, the inspection. So now all of the proper torque has been applied to this disc assembly. When I take it out from between the flanges, that disc is not going to move. It's still going to have its proper torque on it. I can spin it upside down. I can look around. I can move it. And obviously, you have to have some care in handling a disc. And you're able to inspect the disc. And now you can put it back into the system, reinstall your flange bolts, and torque those to just a normal torque value to get your gaskets to seal, and off you go. Here again, though, if for some reason you were ever to remove this disc from even a pre-torqueable holder, the disc should be replaced at that time. Like any pressure relief device, your piping integrity is very important. Frequently, this is a root cause of valve leakage or rupture disc premature failure, that type of thing. If you are not just venting the atmosphere, you want to pay close attention to your outlet piping design and make sure that things are supported securely so that you're not putting undue stress on the rupture disc holder and the attached flanges. And also that as you're installing it, you're not having to force the piping over from a misaligned position to get everything bolted together, because that is going to put lots of stress on your piping. Now, we talked about maybe inspecting holders for wear as part of your inspection process. There are a number of things that can be attributed to severe or premature wear on a rupture disc holder. First one probably is materials of construction. Make sure that you're using rupture disc holders that are of the correct material that will withstand any corrosive media that is going to be seen there. Also, in talking about discharge piping, you'll want to make sure that it is not arranged such that you can get a lot of condensation back down from the downstream piping that's going to settle on top of the rupture disc, that it's going to be drained well, or that you're not getting some condensation from maybe another source in a situation where your discharge piping is on a common header. If you do get material like that coming back down onto the disc, obviously if it sits there over time, it can cause corrosion to the disc holder. It can cause issues with the disc itself, particularly if there is particulate involved in that material settling down on top of the disc. I talk here about how if you get enough liquid in there and it would freeze, that certainly can damage the disc too. The disc pictured there is a scored disc, which is usually a pretty thick material, but you can see it's been dimpled by some downstream force. That's not real easy to do on a scored disc. So there's a couple different considerations when you're installing a rupture disc on a liquid system. Liquid being non-compressible, of course, is going to make a rupture disc behave a little bit differently than if you have it installed on a compressible surface. There are a number of rupture disc designs out there that if you're going to use them on liquid surface, the manufacturer wants you to keep a vapor space underneath the disc in order to help the disc perform correctly. If you don't keep that vapor space for those disc designs, what can happen is even with thermal expansion or very minimal pressure rises in the system, you can cause the disc to crack open, but it's not going to fully open like it's supposed to. And then you'll have leakage and really a lot of maintenance problems and such down the line. So if you're applying a rupture disc on a liquid surface, make sure that you are sure which style you need. Okay, if you're in an application where you're not going to be able to provide a vapor space under the disc, then make sure the vendor knows that so that they can recommend the appropriate disc. Of course, pressure spikes and water hammer, if they are high enough, can affect the operation of a rupture disc just like any other pressure relief device. If you have normal operating conditions that you stay in most of the time, but you have an anomaly and a fast pressure spike, it could be enough to burst a disc and may or may not even register on your instrumentation. So it's just something to be aware of when you're talking about applying these discs, is to know whether or not you have the potential for itinerant spikes in the system. Okay. Avoiding the use of rupture discs on long liquid-filled lines. There's a lot of potential there for pressure rise from thermal expansion or even small pressure spikes that could affect that disc. Eliminating fast closing and opening process valves. Again, that speaks to water hammer and pressure spikes, that type of thing. And you can use different types of devices in the line that can absorb those pressure spikes. If you think you're going to have them, there's equipment out there that you can install to help mitigate those things. Another possibility for a rupture disc issue is if you're dealing with a process that can solidify or polymerize just because of the nature of the process. It's possible it could build up on the inlet side of the disc, and if it's thick enough, it can even form a thick enough shell that it would prevent the rupture disc from being able to operate. One of the reasons that happens is the design of the holder that you use for the rupture disc. Again, if this is a case that you have in your process, you can explain that to a vendor, and then they can work with you to select the right disc and holder combination that will minimize the ability of the material to build up on the inside or on the upstream side of the disc. This shows one method of dealing with that, and this is a device called a viscous T assembly. It's basically very similar to a Weir-style diaphragm valve body, but it has a rupture disc, as you can see on the top of it there, and then the rupture disc would break and then discharge upward out through the assembly. So in this design, this would be an inline installation, so your material is constantly flowing and sweeping over the upstream side of the disc, so it minimizes the opportunity for material to build up there. In addition, this picture doesn't show it very closely, but the seating area of the disc is designed so that there really aren't any crevices between the disc and the holder for material to build up. And if you're not in an inline application like this one shows, we do have rupture disc assemblies that still are designed to minimize that crevice area to help minimize the buildup. Again, we talked about the value of a pre-torqueable rupture disc assembly for your maintenance purposes. Not only are you able to easily remove it from the system, handle it normally, and inspect the disc and then put it back in, but now under most circumstances you would not even have to replace the disc. This can result in longer life using fewer rupture discs and save you on maintenance costs. And again, if you do not have a pre-torqueable holder, the disc should be replaced every time you take it out for inspection. Another possibility of wear and tear on rupture disc holders is you could potentially see some warping in the holder. A holder is made up of two pieces, basically the base, which is the process side of the holder, and then the disc goes on top of the base, and then that's covered with the second component, which is called the hold down. So you can also, during your maintenance cycles, check the base and the hold down and make sure that they are still good and flat and square. This kind of wear, if you can see in the picture there, that rupture disc holder is not very flat. Doesn't look like much of a difference, but that can affect how the disc seats in the holder, and again could cause premature failure of the rupture disc. This kind of damage is usually caused by improper torquing. So we keep coming back to torquing as a very important aspect of rupture disc installation. Maintenance frequency, the question that everybody asks, and there is no one right answer, of course. This is affected by a lot of things. Largely, though, it's up to whatever your facility or your company's safety and maintenance cycle procedures are. Certainly, as a manufacturer, a rupture disc manufacturer is going to say, we recommend replacing your rupture discs once a year. That's not necessarily always practical, but your own experience is really what's going to drive that. As you take the discs out for inspection, if you do it, say, after 6 months and the disc is in really, really good shape, looks like brand new, maybe you can leave it in an extra a year that next time instead of 6 months. So you can make those kinds of decisions. We work with customers on a pretty regular basis, both on rupture disc side and on the relief valve side, to kind of answer some of these questions and help them wade through what they need to consider when setting the maintenance frequencies. 3 to 5 years of service is not unusual. We have quite a few customers who are on a pretty clean service. They're not operating too closely to the set point. Rupture discs are very sensitive to what we call operating ratio. Some of the older design discs really are not supposed to operate over about 70% of your set point. The current design, the newest higher tech designs, can have operating ratios as high as 95%. So these are all things that come into the discussion when you're trying to decide what kind of maintenance frequency. So if you've got a clean service and you're operating well below the disc's operating ratio, and you do regular inspections and things are good, 3 to 5 years is not necessarily out of the question. Another thing that can determine the life expectancy of a disc is going to be cycle frequency. Again, older disc designs, forward-acting disc designs are not very good for cycling applications, and you're not going to get as good a life out of those discs, even though typically they're less expensive. When you apply a good reverse-acting disc that's got a good operating ratio and has a good history of cycling integrity, then you can definitely increase the life of your discs. Again, we're talking about severity of the service. Are you dealing with a lot of corrosives? Are you dealing with clean air or gases? Are you dealing with clean liquids? Are you dealing with something that's very viscous or has a lot of particulate in it? Those are all considerations that have to go into the decision on what your maintenance frequency is. Of course, as you go through your operations, you're probably keeping records of how frequently you're changing out discs and things like that. So you can use that history to help you with those decisions. We typically recommend people to keep spare discs on the shelf because rupture discs are a unique item. They're custom built, if you will. They're built to your desired burst pressure and coincident temperature. And that manufacturing process on some of the newer discs can be as little as 5 days. but that doesn't help you very much if you burst a disc at 440 on a Friday afternoon. So having spare discs on hand is a very good thing. And so you have to also look at the cost of the investment to have spare discs and versus how much downtime you can afford. And the last point there, again, we talked about different vintages of disc designs having different performance characteristics, and it's important that we're matching up the correct disc design to the needs of your application. Okay, thank you. Does anyone have any questions?
I'm not seeing any in the chat, Doug, but we will be following up with everyone who attended and anyone who watches the presentation down the road. And our field service and field salespeople will be able to answer any application-specific questions that you might have at that time.
Sounds good.
So thank you everyone for attending. And again, if you are a professional engineer who needs to keep up on their PE license, you can email us at sales@prenticeco.com. That's PRENTICECO.com. And we will issue you a continuing education certificate. Thank you everyone for attending, and thank you, Doug.
You bet. Have a good day.
Yep, you too.